All right, I ran out of time while I was going through this video, so here is part two. We were on number 4, and I just got through explaining that 2.9642 was, instead of putting 2.9642 in, they just put 642. So on part A, to interpret the meaning of the ordered pair 8688, 80 stands for the year because it's pretty much the exact year they're talking about. So it would be 1980. And then the 688, you just put a 2.9 in front of it. So the lean of the tower was approximately 2.9688 meters. All right, so that's what that means. And then on part B, it says, what is the linear regression equation that models the data? So same thing we've been doing, put the data in the calculator for the x's and put the y's. The x's are the years, the y's are the lean. Then you do stat, calc, linear regression again, and that's going to give you the linear regression equation. It tells you the slope and it tells you the y-intercept. So you just got to write y equals whatever the calculator says, and then plus b, which is whatever the calculator says. And then it says to interpret the slope and y-intercept in the context of the situation. So the slope means that for every year of increase, the lean of tower increases at an average of, now, when you put this data in the calculator, you get something like 9 point something, okay? Now that 9 point something is really, let's see how to explain it. So if you look right here, it would be 9 point something. That would be this number right here. So really, there's 3 decimal places in front of it. So the slope means the lean is going to be something like 0.0009, and then the rest of the slope, because the slope is 9 point something. Okay, so it'd be 0.000. Where am I at? Here we go. I keep going to the wrong page. All right, so, and then the y-intercept is it's a negative number, which means the lean is going to be 0.000 less than the 2.9. So it's like you take 2.9 minus the number that you get, move to 3 decimal places. So we'll say the slope is negative 61. I'm going to tell you the slope is negative 61. So you would take 2.9 minus 0.0061, and that gets you 2.89, and that is how far it would be in the year 1990. Okay, or no, not 1990. That would be what it would be in the y-intercept. Now, based on the linear regression equation, how far will the tower lean in 1990? You take your equation that you had, the y equals mx plus b, and in place of x, you put 90. And just plug it in the calculator, and it spits out the answer. On part D, use the linear regression model to predict the lean in 1981. So again, you put 81 in your calculator, or in your equation, so you put y equals mx plus b, and x is 81. Remember, the m and b is what the calculator is going to give you. What is the difference between the actual and predicted values? So if you go back up here, they actually told you what the actual value was. Whatever your calculator comes up with, compare it to this number. Is it going to be more or less? So there is a difference, but it's close, but there is a difference. Is there a strong correlation between the year and the leaning tower? Yeah, there is, because your R, once you do it, is really close to 1. So it's 0.994, I think. So that is, explain your answer using the value of the correlation coefficient, so the R that you got in your calculator, because it's so close to 1, that means it's a strong linear relationship, positive. So that's it for number 4. So for number 5, for each of the situations, Jeremiah gathered and plotted data, wrote an equation, and noted that the correlation coefficient was close to 1 or -1. He states, since there is a strong correlation, there must be causation. For each situation, answer the question to help Jeremiah understand why this statement is invalid. Explain your answer by giving examples of other variables that might affect the outcome. Children who watch many hours of TV earn lower grades in school than those who watch less TV. So, can it be expected that an increase in the number of hours Jeremiah watches TV will always cause a decrease in the grades he earns? No, because he could be watching no TV and he watches 1 hour, he's watching more. It really just depends on how much he studies and how much he does his work. If he gets his work done and he studies, the amount of TV may not have any effect on it at all. So the next one, there's a positive association between sales of TV sets and the number of obese adolescents in the United States. Does this mean that there's a large number of obese adolescents because of the amount of TV sets sold? No, you could put the TV in front of a treadmill. So, lack of exercise is what would cause that. So a study in elementary school children 6 to 11 found high positive correlation between your shoe size and the score of your reading comprehension. So these 3 kids have the same shoe size. Does that mean they're going to have the same score? Obviously not. Some people like to read, some have test anxiety and things like that. And that's why that one would be, just give some example to why these are all invalid. These 4 questions are actually the easiest on the whole worksheet. Okay. There is a strong positive correlation between the number of firefighters at a fire and the amount of damage a fire does to a structure. So does that mean if there's a small number of firefighters, they may not be able to fight the fire as well? So if you got a large number of firefighters and it causes a large amount of damage to the structure. So other factors that contribute to that is the size of the fire, the type of the structure, what caused the fire. If it's a gas fire or chemical fire, it may be harder to put out. So that finishes off this worksheet. So if you have any questions, remember, you can always email me or join us in the class through a Google Meet, because I open the Google Meet during your class period every day. And then 2nd and 8th period, I can always Google Meet with you, and you can share your screen and I can share my screen, and we can get together and make sure that you get everything turned in. So if you have any questions, let me know.